So in this video, we're going to introduce the idea of domain and range in the context of a relation that's represented with a bar graph and a relation that's represented using mapping notation. We'll do equations and graphs of equations in a separate video so that we can kind of chunk the homework up into smaller pieces. So domain and range are two of the more important concepts or ideas in college algebra. And domain is simply, if you have a set of ordered pairs, the domain is the set of all possible or valid values that your independent variable or input variable can take. And the range is simply the set of all possible or valid values of the dependent variable, or remember, the dependent variable is the output variable. So in the first video we talked about relations having inputs and outputs, independent variables, dependent variables. Domain is simply come up with a way to describe all of the possible valid input values, and the range means simply come up with a way to describe all of the possible valid output or dependent variable values. So here we have a relation in mapping notation. It's the same, one of the relations we looked at in the previous video. And in this mapping notation, we have different hikes that you can take. That's your input or independent variable. And these are being mapped to the distances that you have to hike if you want to go on that hike. So these distances are the output or dependent variable. The distance you walk will depend on the hike that you choose. So the domain is going to just be the set of all inputs, and the range is simply the set of all outputs. So when we describe these, we're going to describe them in set notation, and we don't want to use x and y to represent our input and output variables because we have a contextual problem. So I'm probably going to represent, if I'm thinking about ordered pairs, I want to think about them as being input hike, output distance. So D for distance, M for miles, something that makes sense to you, maybe M for miles. So you start off by defining what you want your names to be. So hike, we'll represent that with H. Distance, we'll represent that with M. And so the domain is simply going to be the set of all possible inputs or hikes. So you say, hey, the hikes, H, are an element of the set notation like we've seen earlier this semester. And then you just list the elements in that set. Hey, here's the domain. It's American Lake, comma, Twin Sisters, comma, Dewey Lake, comma, and Natchez Peak Loop. Natchez Peak. There's the domain. And for the range, it's simply the set of all possible outputs that we can get if we select an element from the domain. So if we select one of the four elements from the domain, the miles M, I'm using M to represent my outputs, are simply an element of the set that contains these numbers, and you want to list them in ascending order. And if one number shows up more than once, you only list it one time. In this case, each element is unique. So I simply list them, and now I have listed all of the elements in the range of this particular relation. Here's another relation that we saw in the previous video. This is the last example we'll do of this type, and then we'll shift gears over to equations and graphs of equations. But here, if I want the domain and range, I would simply say, hey, I recognize that the inputs are the years in college and the outputs are the GPAs. So here's my input variables. Here's my outputs. Give them a name to represent them. So I'm going to represent the inputs with a big Y. That will represent my years. And I'll let big G represent my GPAs. And then for the domain, we simply list the elements in the set of valid inputs and outputs. So domain is going to be the year. So the year is an element of the set that contains the numbers 1 through 5. So I list them 1, 2, 3, 4, and 5. And my range is simply going to be all possible GPA outputs. And based on my graph, my GPA outputs are going to be an element of the set, and I want to put them in ascending order, so I'm going to get the smallest GPA first. So this bar is corresponding to an output of 2.75. This bar here is corresponding to an output of 3.00. This bar corresponds to an output of 3.25. This bar corresponds to an output of 3.50. And this bar corresponds to an output of 3.75. So there's the range of my relation. So again, domain, all possible inputs, range, all possible valid outputs.